Good morning all. Today we will solve a numerical question on digital negative. A 3x3 digital input image it is given to us, and for the same we have to compute its digital negative. So let us solve this question. So this is our digital input image, and for this given digital input image we have to compute the digital negative. So we know the mathematical equation of digital negative. It is S equals to L minus 1 minus R. So in this question, number of bit n it is not given to us. Total number of gray level L it is also not given to us. So for the same, in this given digital input image, we will target the maximum intensity value. The maximum intensity value in this given 3x3 digital input image, it is 245. So now we will represent this decimal number 245 into its binary equivalent, into its binary format. So the binary representation of this decimal number 245, it is 11110101. The minimum number of bits required to represent this decimal number 245, it is 1, 2, 3, 4, 5, 6, 7, 8. So the minimum number of bits required to represent this decimal number 245 in binary format, it is 8. So n equals to 8. If n equals to 8, we know the equation of L. L equals to 2 to the power n. So if n equals to 8, L equals to 2 to the power 8, that is equals to 256. So now we got the value of L, that is 256. Now the value of L, that is 256, we will substitute in this equation and we will obtain the equation of S. So in place of L, we will substitute the value 256. The equation of S becomes 256 minus 1 minus R, that is equals to 255 minus R. So now we got the equation of S. S equals to 255 minus R. So in order to compute the digital negative of this given input image, we will apply the equation of digital negative S equals to 255 minus R on this given digital input image, and we will determine its digital negative. Since the dimension of the given input image, it is 3x3, so the dimension of my output image is also 3x3. Now pixel by pixel we will compute the output value. Now by pixel we will do the computation. First, for this pixel, the intensity level is 120. So for this pixel, the input intensity level, that is R, is equals to 120. We will apply this condition. We will apply this equation S equals to 255 minus R. If R is 120, the value of S that we will get, it is 255. In place of R, we will substitute this value 120. So the equation of S becomes 255 minus 120. If you do the calculation, the value of S, it becomes 135. So for this pixel, we got the output intensity level, it is 135. Next, for this pixel, if R is equals to 152, in this equation, in place of R, we will substitute 152. So the equation of S becomes 255 minus 152, that is equals to 103. So for this pixel, we have obtained the output intensity level, that is 103. Next, similarly for this pixel, that is for the intensity level 205. So if R is equals to 205, the equation of S becomes, in place of R, we will substitute this value 205. So the equation of S becomes 255 minus 205. It is equals to 50. So for this given input intensity level 205, we have obtained the output intensity level, that is 50. So here I will write 50. Similarly, for this pixel, the input intensity level, it is 224. So R is equals to 224. We have to determine the output intensity level. So in this equation, in place of R, I will substitute 224. The equation of S becomes 255 minus 224. That is equals to 31. So for this given input intensity level 224, we have obtained the output intensity level, that is 31. So here I will write 31. Similarly, for this input intensity level 220, if you compute the output intensity level, similar approach, in this equation, in place of R, I will substitute 220. So the equation of S becomes 255 minus 220, that is equals to 35. So for this given input pixel intensity level 220, we have determined the output pixel intensity level, that is 35. So here I will write 35. Similarly, for this given intensity level 210, so if R is equals to 210, the value of S, in place of R, I will substitute the intensity level 210. So the equation of S becomes 255 minus 210, that is equals to 45. So here I will write 45. Similarly, for this pixel intensity level, that is for 235, if you determine the output intensity level, that is in this equation, in place of R, I will substitute 235. So the equation of S becomes 255 minus 235, that is equals to 20. So for this given input intensity level 235, I have obtained the output intensity level 20. So here I will write 20. Similarly, for this pixel, the input intensity level, it is 244. So if R is equals to 244, in order to determine the output intensity level, in this equation, S equals to 255 minus R, in place of R, I will substitute 244. The equation of S becomes 255 minus 244, that is equals to 11. So for this given input pixel intensity level 244, I have determined the output intensity level 11. And finally, for this pixel whose input intensity level, it is 245. So if R is equals to 245, we have to determine the output intensity level S. So in this equation, S equals to 255 minus R. In place of R, I will substitute 245. So the equation of S becomes 255 minus 245, that is equals to 10. So for this given input intensity level, 245, I have determined the output intensity level as 10. So for this given digital input image, we have determined its digital negative output. This is 245. And with this question is over. Thank you all.